Hello, good morning. Can you see the screen and am I audible?
Yes, Freddy, you are audible.
I think we are around 30. Should I start or should I? Because not everyone is here yet. Okay, I will just start since time is going, and then we'll start slow, and then we can change the speed as we go as new people will be going on joining. So today we'll be covering the exploratory data analysis. For short, we'll be calling it EDA or EDA. My name is Fred Damon, and then I'll be together in this topic. So the topics that we'll have, we'll be covering, we'll have the the introduction. It's supposed to be there. We'll have the introduction, and then we'll cover some different concepts of EDA, which are a little bit many. I just thought I write it as the concepts. And then we'll cover types of exploratory data analysis, which is there are three. So we'll see them. And then we'll get to see the conclusion, which we'll be discussing about everything that we have seen in EDA. What are we supposed, what will be the main or major takeaway? So starting with the introduction, the EDA exploratory data analysis is the process of examining and visualizing data sets to summarize their key characteristics, often with the help of statistical graphics, plots, and the information table. So that's the definition from the actual words from which are written in this PPT. But we can try to understand exploratory data analysis is basically when we are going to generate or we are going to develop machine learning and AI and deep learning, all that. In order to be able to do that, that means we require data. We require data set. So before doing anything with the data set, before starting creating anything on the data set or starting to do anything, the first thing that we suppose or we should do, we're supposed to do exploratory data analysis on the data set. Why do we need to do that? We will see in the next few slides. But the action or the process of examining the data set that you are given so that you can understand the key characteristics, what is in the data set, the size of the data set, what keys are there in the data set. That's the important part of anything. That's the important part of before we start the uh, AI generation or ML generation going forward. So from this presentation, at the end, we need to be able to understand how to summarize the key concepts and why summarize the key concepts. Which one I just explained, why summarize the key concept, and how to formulate hypotheses. So with this presentation, later on we'll have a demonstration, hands-on demo to see how exploratory data analysis is and what are we getting or what are we formulating from exploring the data sets. So the purpose of exploratory data analysis is to include understanding the data structure, It includes identifying pattern, trends, and anomaly in the data set, because you may be given a data set which may be having blanks, which may be not having all the data as clean as it's supposed to be. So you need to understand the pattern, if or trends or anything anomaly in the data set. For example, one of the anomalies which we usually see in the collection of in the data set, you may be given a data set which is, let's assume, in CSV or it's in Excel. And then in the area where it's supposed to be age, you might find it's written in strings, like someone has written 22 in string and has not write the number 22 as their age. That's one of the anomalies can be there. Or someone may written in the field where it's supposed to be age, someone may have put a phone number there. So that we usually treat it as an anomaly, because it's not supposed to be there. But if you start dealing with a lot of data, stuff like that may start happening. Anomalies like that you may start seeing them. So another purpose is to be to check the assumption required for modeling. So if you already understand, you explore the data, you will start creating the assumption which you will start with. For example, if you are doing exploratory data analysis and you see your data is how do I say, it's falling to using of particular model, or it's either supposed to be used decision tree, or that you can see which modeling will you be required based on the data that you have. Another one is to which detect missing value or outliers, which is same, almost similar to the one which is identifying anomalies, and then form hypothesis or guide further analysis. When we are doing exploratory data analysis, we don't have hypothesis yet. We are just having the data set and then we are starting exploring it. So later on, we'll see furthermore. This is still some key reason why exploratory data analysis is important. It's not that much different with the purpose. Developing It include developing an initial understanding of data, understanding the distribution of data types, value range, and pattern. So you get to see just if the data is normal, what is expected of the data, just simple thing like that. And then second thing is detecting errors and anomalies, and then guiding data cleaning, feature engineering insights. All these are parts of why we are supposed to see the data, why we are supposed to explore the data set before starting doing anything. So a part of detecting errors and anomalies, we need to identify missing data, inconsistent, catch data entry errors or unexpected duplicates, all that. In guiding data cleaning, we will be what will basically it will be, what type of cleaning will be required. If you already know, like some of the data are missing or some of the data are appearing not in the right data type, so you will know which type of cleaning should you do first, because you cannot go for dropping a features before you try imputation. So all that is will be guiding you on how to do the data cleaning or anything that will be regarding to data, so you can have a better understanding of the data. And then the next one, it will be, it's give you insight on doing feature engineering. Feature engineering is basically, once you have a data set, assume it's in Excel, what feature will you be requiring to use them in your model development or in your machine learning development? Which features will you be using? So that's feature engineering. And then communicating the finding. This is the most important thing, because nowadays we are students and scholars and facilitators. We are basically teaching, and we are basically learning. But apart from this, if we go to the real world, communicating the finding is most the important thing in data exploration. So you're given a data set. Let's assume you're given a data set and you are about to write a paper based on the data set. So you are about to generate a machine learning from that data set, and then from everything that you do, you want to write a paper. So the first thing you'll do EDA on the data set. You'll communicate the finding which you have before the data set was touched, before it was given any pre-processing, like imputing or removing missing data and dropping any features, dropping any column. You need to show what was happening, what the data set was having. And after you do all the features, you can communicate the finding of the data set later on after you already process the data. So with EDA also, it's help communicating the finding because the stakeholders or the people who will be reading your paper will be needing to have a clear understanding and not way too much words on your not too much words on your paper. So you're just communicating it using you only be using visualization to communicate. So the last one, the importance, it's model selection and algorithm suitability. I think I talked a little bit about this. If you're doing exploratory data analysis and then you see your data showing a linear trend, so that means the model that you use for machine learning in your training, you'll use linear models. If your data is showing non-linear distribution, then your model or the algorithm that you'll go with in developing of machine learning, you'll use also non-linear. So it's basically you'll be able to see all that. Going off from the importance to tools, there are different tools based on different languages, which can be used in exploratory data analysis. We'll discuss the one which are in Python because the later coding will be doing it in Python. This other one, they're in R, but let's start with the one which are in Python. So there is a library which is for Python, which is called Pandas. The purpose of Pandas in data exploratory data analysis, it's data manipulation and analysis to handle data frame, to handle missing values and grouping. This purpose, I've just summarized it, I put it as an abstract, but there is more purpose of pandas more than this. So we'll see it once we start doing the hands-on demos. And then we'll have NumPy, which is a numerical operation or useful for all statistical calculation. We'll see it. And then we'll have matplot library, matplotlib, which is basically for basic plotting, the line, the bar, the scatter, the histogram, and all that. And then the next one, which is Seaborn, which is statistical data visualization. It's a little bit advanced more than Matplot. It's advanced and beautiful plots like heatmap and pair plots. So both Matplotlib and Seaborn, they are used in drawing. One is for basic plotting, another one, Seaborn, is for a little bit advanced plots. And then we have Plotly, which is interactive visualization. Interactive visualization, that means the visualization will be able to interact with. You'll be able to see different sides of the visualization. And then Altea, I don't even know how to pronounce this, but it's used for declarative statistical visualization library. SqueezeViz is automated data reporting generation. So this library is used for automation, but we'll see why you shouldn't do automation if you start to understand the data first as we are starting learning, and then later on we can go for automated data report generation. And then we have Panda profiling, which will be generating a full HTML data report with distribution, correlation, and missing values. Then Detail will be creating a web-based UI to inspect Panda data frame interactively. So all these are libraries which are almost automating the exploratory data analysis. And then AutoViz, which automatically visualize data with minimal code input. So when we say exploratory data analysis, yes, we still have code at some point because you need to be able to understand the data. We are exploring the data set. If you are exploring the data set, at some point you will be requiring the code. And the code will be involving just to explore the data set. That's it. So this one are in R. I don't think we'll be writing R, but I just included it so we can understand not only Python can be used for exploratory data analysis. This will just skip, but I will already included here if you want to go with them. So with this introduction, basically, we are exploratory data analysis. We need to understand your data set that you are having, that you'll be using to generate the machine learning, to develop the machine learning and deep learning. Why does it matter for you to understand that machine learning or to understand the data set? So before we do anything, before we do any cleaning of the data set or modeling or visualizing, it's very important to understand what your data contains. Why do we need to understand what your data should contain? Because we are going to clean, we are going to model, we are going to pre-process the data. If we are going to pre-process the data, we need to understand which data types that the data sets features have so that we can to know which data you have and then understand column data types and basic structure of each feature so that you can know which way to clean, which way to model, which way to visualize. And then the last one is to detect early warning signs. These warning signs you'll be seeing from the dataset after when you are exploring the dataset. You'll be seeing if there are any missing values, there's wrong types. Someone was supposed to be putting int, they put strings, they're supposed to be putting float, they put integers and all that. So exploratory data analysis help us know most of this stuff before we start dealing with the dataset. So in order to be able to reach this goal, you need to be able to ask yourself, what is the size of the data set? What do each of the feature means? So if you're having a feature, someone collected a data set, and in the field of let's assume it's age, you collected age as integer. Have you ever wondered why in the data set of let's say even school, a data set of school, they don't collect age. They always ask, when were you born? They collect the dates, when were you born? They don't collect the age you currently have. If we have uh, uh, the date when you were born, your age is always a derivable value. We can always calculate your age for any time, for any period that we want to know your age. So with exploratory dataset, you'll be understanding what type of feature for each variable, for each column, or for each feature column your dataset has. So we also be needing to be able to understand all relevant variables which are present in the dataset. So dataset structure overview. Now we are starting seeing a little bit of the coding or the functions which will be doing some purposes. The previous we are understanding the goal. Why do we need to do exploratory data analysis? So next we'll be seeing we are supposed to be importing pandas as PD. PD is just a placeholder or variable which will be later on used so that when we refer to PD, we'll be referring it to as Panda. So using PD, we can read our CSV. After reading our CSV, then we'll store it in DF. And then from variable DF, that's when we can start showing different structures that we use to overview or to see the data set. So if it's df.shape, we'll be seeing the rows and columns. How many rows and columns that our data set have. If we use df.columns, it will be listing all the columns named inside the dataset, which in this slide, our dataset will be that data.csv. If we say df.dtypes, it will be showing all the data types of each column. So if you already see the column name and you are seeing dates, and then you're seeing the data type of date is string, or the data type of date is integer, you'll start realizing before going for pre-processing or starting data cleaning, if your data for age is not what you expected the data type to be, You start cleaning or you start dealing with that data head on early. So we'll have another function which is df.info, which it will be giving you summary of column types, nulls, and memory usage of the dataset. Another one is will be df.describe, which will be summarize the statistical for numeric features. So all these are giving you the dataset structure overview. Remember, structure overview, not the entire dataset overview. So the data types which you'll be seeing, for example, if you run the command for data type df d type, it will show you int, it will show you floats. So once you see the data set as int 64 or float 64, that means the data that are stored in that column or stored in that feature column, it will be either numeric, it's basically be numeric. Even though when we say floats, that means it will be in the numeric which are having doubles, which have floats. So if you see object or string, the data can be categorical or text data, or we refer it as strings. And then date time, it will be referring to date or date data or timestamp. It's all that still the same data type. So why data types? If you need to understand the data types, each column with the expected data types. So if you are having a wrong types, which can be leading to a wrong insights. For example, if you're having an int or float feature, which the data type inside the data set is given as a text or as a string, which means you'll be having difficult processing it. You'll need to clean or to be able to convert the data set to the right data type, so you can be able to process it. For example, age, I'll be using age a lot. We'll need to store it as a date type. We don't need to store it as int. But if there are still usage where you need to store it as int, so it's depend with the usage of the data side of the data set which you'll be going to use. Date can be stored both using int, and then later it can be stored in date type. Both have their own usage. So when is age need or date of birth required to be stored as date type? When we need to be able to process or to get the age, calculate the age of that person anytime we want, we will need to store their date of birth as date of birth. And then when we don't need to calculate a new age every time, we only need the age of for example, when we are using a data set and then we are trying to capture a picture of a plant, and then we need to remember this plant was, let's say, 3 months old when this picture was taken. We don't need to recalculate that number. We need to store it as it is. Then we'll need to store it as an integer. So why do we need to understand the data types? Is so that when we are going to view or we are exploring the data set, we need to understand the correct data types which are stored along the features, so we can have the correct insights and basically move on with the machine learning later on. It helps choose the appropriate analysis technique and visualization. You're having a data type which is categorical. When you're having a data type which is supposed to be object or string, the way you analyze it or visualize it, it will be a bit different with the data type which it is int or float. So all these revolve about being able to do the data analysis or to do the exploratory data analysis, so that you can know which technique you'll be using on with processing or even with the exploratory analysis itself. Because we'll be drawing a lot of visualization. To be able to draw visualization, you need to have the correct data type. Okay. So after we understand some of the importance of the data types and their significance, we need to go to why data cleaning is matter. I think the first session the first day, we heard this say that uh, if you are having poor data, that means your model will also produce poor results. So that's one of the things why we need to have good data, or why we need to have clean data. You can have data set, but you need to ensure the data quality, accuracy, and reliability. The data itself, it need to be quality, because you cannot develop a machine learning that is having of quality, that is quality, without having data that is quality. You cannot develop a machine learning which is accuracy while the data you're having is not accuracy. So you need to ensure all these three. You need to have a data set which is reliable, so you can be able to develop a machine learning which will also be reliable. Because we said the machine learning, anything that we need to train the machine to understand the way we human behave, it need data. So that data, it need to be all three: quality, accuracy, and reliability. And then why we also need to do data cleaning, we need to prevent misleading insight or broken models. Misleading insights is when you're having a data. I'm trying to find a good example of misleading insight. Okay, we can have misleading insight. For example, let's say we're having a data set which having employees and their salary. If you do not clean your data well, your data set may end up showing like someone who is junior in the company can be having a higher salary than someone experienced. How is that a misleading insight? It's a misleading insight because mostly, generally, I'm just saying this generally out of the blue, that someone who is experienced in the work or in the company will generally have more salary more than one who is junior. So your data sets is also supposed to be showing the same insight if you do exploratory on it, if you do exploratory analysis on the data set of that company. So you need to be able to get the same features that are expected by which is as an expected outcome by the normal environment. So if we say something is supposed to be A and then B follows. So same way when you are exploring the data, the insights should also be showing similar trend, like A start and then B follows. So that's the kind of why we need to do the data cleaning. Also, it enables effective EDA and modeling. Before it enables effective exploratory data analysis and modeling. Exploratory data analysis, you need to get to view the data. As I said, you need to show the data set structure. So after viewing the data set structure, you'll actually already started exploring the data. So when you already exploring the data, we'll see it furthermore when you draw some of the charts. And then from there, we'll see how effective modeling come into play when we have an effective exploratory data analysis. I think I'll explain it much more better later on. And the next slide, which will be showing the common data issues. We already started explaining the missing values. Missing value is basically when the data are not present in the columns. You have data, but some of the columns are missing. Some of the values in that feature are missing. That's a missing value. Outlier, these are values which are extremely not normal to the column, which are not normal to the feature. Thus, we can define it as outlier. So, for example, if we have an age column or an age feature, and then someone turns out to be put a phone number, which will be reading at least 10 numbers, that will be definitely an outlier. Or someone we can term it someone is aging 150. We can see it's not ranging to the same values of other, most of the values which are inside the feature. So that will term it as outlier. Duplicates is when we are having more than one entry which has similar values. So we are having value, for example, it's a employee data set. If we have employee data set, if we have a person called Amon, we don't expect to have the same name, same salary, same everything, same employee named Amon. That will be a duplicate. Duplicates can be allowed. It depends with it can be people with similar last name. That is totally basically actually not duplicates because there will be two different people. But if it's a data set of employees, and then we have same entries for each field, for each column, for each row, we will be considering it as a duplicate. And then we will have inconsistent entries. I think we just explained it's very similar to outliers. This is the entries which is very abnormal to the columns. It can be inconsistent in terms of data types. It can be inconsistent in terms of types. It can be inconsistent in terms of what is written is not understood, or it was the value which is present is not adhering or is not normal to the value which was supposed to be there. So you can have values, for example, in column, which column should we use? For column age or for column date, and then someone can write value as name. So that will be an inconsistent. And then we'll be having wrong data types, whereby we already explained it much further when we were discussing data types. Data is supposed to be having date or time. Someone has included the data which is not supposed to be having that type of data type. So these are some of the common issues in the data or in the data set. So this is also a reminder and not garbage in, garbage out, because we are doing exploratory data analysis. So we can have a good quality data, which can have a good quality machine learning, which can be giving a good quality outputs. So going how to handle missing values. This is the first thing. We start discussing the first issue, which is missing values. So how to handle that. Remember, DF is the variable after we read our data set. So we need to be able to how to handle missing data. How to handle missing data, we can use here use axis is equal to 1, but we can use mod. We'll explain it also a bit later. There is min, mod, and then there is another one, min, mod. There are three. I think I'll check them. So apart from this, we will be able to feed the missing data by either calculating the mean of the entire feature or entire column, and then substituting the mean to the feature or to the row which was empty. That's one way. Second way, we can use the data which is most it's mostly in the middle. We can use that to substitute to a value which is missing. We'll see if there's something I'm forgetting. It's supposed to be 3 values. So handling missing values, dropping rows or columns. First, we are allowed to drop rows because the data set will be having but we cannot drop columns. We are supposed to drop columns, but you will need an expert to help you to tell you which column to drop or which column not to drop. I'm saying this because assume you're working with the data set for healthy or from healthy departments. If you drop a column, you can be dropping a column that is useful to detect a particular disease, because we are computer scientists, mostly data scientists. We are dealing with data. We may not know which which columns are important or not. So in order to be able to drop a column, you need some consultation from the expert from that field. So they can confirm this feature is not so important, and since it's having a lot of missing values, you can drop it. Dropping rows is okay because you'll be having many rows. As you will be allowed to drop also rows if, let's assume, when are you applying to, when will you be allowed to drop rows? Assume you're having a data set which is having 10,000 rows. And from these 10,000 rows, only like 500 rows are empty. So from 10,000, if you drop 500 rows, you'll be having 9,500 rows which you'll be using in your data set. This is total okay, since the rows which are empty or have missing value, they're very minimal. But assuming you have 10,000 rows and then you have 5,000 rows which are empty, I don't think the strategy of dropping rows will be applying, because if you drop 5,000, that's almost half of the data set, half of the rows. If you drop half of the rows, then your data, your machine learning will be missing a lot of features which you already dropped. So we assume, we will always say, if you'll be dropping rows, the rows that you'll be dropping at least should be only 1/4, a quarter of the entire data set. So if you're having 100 rows worth of data set, you cannot drop more than 25 records. It will also depend with the machine learning and the data set again, which you'll be using. That's why the first strategy of dropping rows and column, especially column, you'll need to consult with the specialist from your field that you'll be working on. You cannot just drop column. Dropping rows, you just check the rule of thumb. You cannot drop more than half or more than a quarter of the entire rows which are present in the data set. Then you'll be having a wrong data. The second strategy, which is imputation, this was the one which I was trying to remember, using mean, median, and mode. So if your column, if your feature, if your feature column in the dataset is numerical or categorical, it has, you remember this phrase in the front, with low missing rates. That's when you're supposed to do imputation. Imputation basically, we mean when there is a missing value, we are supposed to replace the missing value with the mean, median, or mode. That's it. And then domain specific filling. Example, fill with unknown or zero. There'll be, when we say domain specific filling, you have a column which has missing values, but those domain, those missing value, you can just fill them with a value which you will later know. You don't know. It's not like a missing value. For example, if we collect a data set, it has a column name, and then it has column gender, and then it has column thoroughly, or any column that we want. But out of these three columns, name, gender, and thoroughly, there is a column, when they were collecting the data set, they genuinely didn't want, they weren't able to know that particular feature. So you can just place it with unknown. It's not missing value. It's basically unknown. Like that is the feature. When we were going to collect a data set, we couldn't know what type of salaries the employees were being paid. That is like not known. But I use that as a simple example. But when it comes to domain specific, for example, you're going to collect a data set on rice, and then you need to understand the variety of rice that was planted. You need an expert to be able to know that. So if you did an expert, and then the expert is missing, let's assume, for the entire time you're collecting the data, those columns which you are supposed to be feeding with the paddy variance or the rice breed, it will be unknown to you. So you'll be feeling it as this value is unknown at this time. So you can handle it that way. And then forward and backward field. This is for time series data. When we say time series data, we meant like weather data, stock market data. You have the data which is always having the same features, but the only difference, the only huge difference in this data set is like it ranges across different times. So you can just forward and backfill the same data so that you can handle the missing values. This is the first way. This is the first of handling those data issues, which will say the handling missing values. The second one is detecting and treating outliers. We said outliers are data which are out of the ordinary. So detecting rule of thumb is just checking the data that is out of the ordinary. If you're checking for age, we're expecting age to be in particular range. If you're having a data set and it has age, people having 200 years, unless you are in Japan, you need to be checking that is basically it may be ordinary or not. But 200, we usually term it as out of ordinary for value age, right? So also in salary, you can have someone paid a huge amount of money, which if you check for the employee data set, and if you evaluate the company worth, you're finding someone's salary is huge than the entire value of the data of the entire value of of the company. You start realizing that can be an outlier. So the rule of thumb for detecting outlier is just to be able to see which data are out of the ordinary. So that's the first one. But when we're going technically, we'll be needing to use this method or this function, which is we'll be using box plots and then the IQR method. These are the methods which will be able to detect the outlier in the data set automatically. And then that was detecting. Treating outliers. Outliers can be something out of ordinary. Actually, it's something which is out of ordinary. So the first uh, thought is either to remove the data, but the last option, treating the outlier, is to treat it as a separate category. For example, if you're detecting and treating outliers in the in a log. When I say log, like network log, let's assume you're an expert or you're data scientist for the university data logs, the network logs. If you're seeing outliers, it can be an attack because it's out of the ordinary. That could be an attack. It could be an attack. If you remove it, that means you deleted the data, which could potentially help you to be able to detect an attack. So treating outliers, it also depends with what type of data you're dealing with. So if you're dealing with very sensitive data, for example, also again in medicine or diseases, treating outliers needs some seriously expert knowledge to be able to tell you as a data scientist to remove or to keep it as a separate class. Because you may have something that is outlier in security and in medicine, but for the people who are expert in that area, they may tell you it's an outlier in the data scientist point of view, but in our case, it can help us understand the disease better. So whether to remove or to treat it as a separate category, you need to be able to agree or you need to be able to get help or understanding from the expert of that field. Cap, we need to replace extreme value with upper or lower limits. This is basically we are doing like imputing when we are dealing with the missing value. So basically, you're removing the extreme value with upper or lower limits. Upper and lower limits the ways also to be able to when we're doing exploratory of the data of each feature, you'll be able to detect which is the upper value, which is the lower value. For example, in the salary column, lower value, we expect it at maximum, lower value should be 0. But if you're seeing in the column salary, someone has negative money, I don't think anyone can be having negative salary in whatever case that can be happening. So treating that outlier, you may treat it by replacing it with the lower limit or upper value. So someone is having a salary more than the entire worth of the company. The best thing you can treat is to give him the highest salary in the company. Because if he's having more salary than the company was, that means it's impossible that to be his salary. He need to be given. You need to just imputate it to replace with the most upper value. So you need to able to understand that. You need to be able to understand with what type of data you're dealing with, so you can be able to be able to see. You need to remove. You need to do cap or imputating, or to treat it as a separate category or class. So that is detecting and treating outliers. Other data formats. We discussed duplicates, and we said duplicates is when the entry is similar in more than one column. That means when we identify that column using primal key, we identify it as duplicate. So mostly the best way to treat duplicates is just removing the duplicates. Because if you're having duplicates, even your machine learning will be treating it as different rows or different entries. And then later on, it will be like remembering those, it will be having the overfitting problem. It will be remembering the more duplicate value. Meanwhile, we need your data set to be balanced out. The other data set, other data formats, how to treat it, correcting inconsistent data entry. For example, you're having misspelling, you need to be able to correct it so the data set can be appear correctly. We have case sensitive. Case sensitive is when you write a letter, the data are written in a form like, if it's caps letter, it need to be caps letter. If it need to be all lower letter, it need all to be in lower letter. Another one is in consistent units. If you write 100, let's assume our data set is for the people who will be running for the marathon. Let's assume after this training, we'll be running for a marathon. And we collect a data set of the people who will be running the marathon. If we write, we'll be running 100 meters. I'm pretty sure most of people will be able to run 100 meters, even if no matter what you eat or what you didn't prepare for the running, 100-meter, most people will be able to run. But if it was an inconsistent unit, it was supposed to be 100 kilometers. I don't think that's already a different value. 100-meter and 100 kilometers, that's a different two different units. And they mean two different things. So inconsistent units, you need to be able to give it accordingly to the actual unit which was supposed to be while we were collecting data. And then the encoding issues from categorical to numerical, you need to be able to encode correct values so that when you start processing, the data be appearing the same. Okay, feature engineering. Okay, let's discuss feature engineering. So after showing this, the last slide for how to handle the data issues we just discussed. So next, we'll be discussing the feature engineering basics. So basically, in the feature engineering basics, you need to be able to see if you're having a date, we can extract the year, month, or weekday depending on what we need. So this is just an example. And then we have binning, which is converting age into age groups. Each row that may be collected in the data set may be converted into age. Like we can say these are the people who age were 10 to 20 and then 21 to 30. That's basically grouping the age into age group. It can be required based on the data set which we'll be doing. So this is just a little bit of feature engineering basics. You can try to build the data set as it's required, as your data set requirement. Meaning it's necessary for some data sets, it's not necessary for some of the data sets. For example, if we need to know, we don't need to know exactly age of each person in the data set. We can do the binning. If we need to know, then we are not supposed to do the binning. Interaction features. Multiply price quantity for total cost. I think there's something missing from this interaction features. And then the last one hot encoding, converting categorical to numeric. You need to be having encoding so that, because we remember all the data mostly, it's easy to deal with when they are in numeric form. It's deal to be able to explore them when they're in numeric form. When you're having categorical, it's possible, but it's a little bit of long way. So mostly we usually prefer encoding the data so that we can be able to deal with them easily. I think we're remaining with some 25 minutes. Let me go a little bit fast. Any question on the introduction and the features we just covered up to now? Okay, I'll start with the types of exploratory data types, exploratory data analysis. There are three types of exploratory data analysis. The first one is univariate analysis, which is showing the word uni, which means one. And then we'll be having bivariate analysis, which is seeing bi, which is means there'll be two. And then multivariate analysis, which will be having multiple data, multiple columns. So starting with the first one, uni, which means once focus on studying one variable to understand its characteristics. You'll be having many columns in the data set. In univariate analysis, you will just be studying one. We'll see the procedure or everything that goes in univariate. The second one is bivariate, will be focusing on checking the relationship between two variables to find the connection. So we'll be seeing those here. And then multivariate analysis will be identifying relationship between two or more variables in the data set and aim to understand how variables interact with one another or affect one another, and which is important for statistical modeling, which is not important. So these three types, we are supposed to be learning the theory from each one. And then when it comes to demo after break, we'll need to be doing a demo from each of these three types of the exploratory data analysis. So starting with univariate analysis, which we'll be discussing it in depth now, we need to be understanding how numerical features is spread across its range. If it's spread across its range, we need to be able to use these types of graphs, histogram and kernel density estimate. You can also use line graph. It can be put in here. This is the bar chart, which is basically any histogram can fit to be able to show the distribution of numerical value. So assuming we are having a data set which is having data spread, it's having this numerical variables which are in the data set. We need to be able to see how the data spread in the same column. We can draw using the histogram. So using the bar chart, assuming we are having a data set for thoroughly of people, and we need to understand only that thoroughly how it is. We need to see the maximum, the minimum. You can just take that same column, you draw it in the histogram or the bar chart or line chart or kernel density estimation, and then you will see who get the highest salary or which one is the lowest salary. So that's it. We'll need to be able to tell the central tendency, these three variables, mean, median, and mode. I think these are just basic from previous classes. So mean means average, median means middle value, and mode means most frequent value in that column. So these are also can be used to measure univariate analysis, can be used in univariate analysis to measure the central tendency. You're having single column, you're trying to understand that single column alone. Again, you can check the spread and shape, variances, skewedness, and kurtosis. If you need to check the range, you can just take the maximum minus the minimum. If you need to get the variance, you can check the average squared deviation from the mean, standard deviation, squareness, all that you'll be able to get from that single column that you'll be exploring. So if it's skewedness, that means there will be a asymmetric distribution. If it will be having kurtosis, it will be having peakiness in particular, in particular, how do I say, if you draw a chart, it will be having peakiness, tailediness. Yes, it will be having peakness. I don't get it how to explain it, but it's kurtosis, it will be having peakiness. So it's still in a univariate analysis, we'll be having distribution of categorical value. I think I just explained this. Distribution is not that much yes, same as distribution of numerical values. So you can use the bar chart to count the comparison among the same. This is for numerical value. You're having salary, you need to see the maximum and the minimum. You can put it in the bar chart or line chart. Pie chart, if you're having categorical value, you need to show how much each values is each value, how much do they share. That's why in brackets, it's written news with few categories. You're having a data set, you're having a column that you need to see proportion of each category. You can use pie charts to be able to show it. So basically, this something you need to take from this univariate analysis is we'll be analyzing single column alone. So with anything that you'll be doing, you need to be analyzing only single column of the data set. So if there is any question on univariates, I'll go to bivariate analysis, where we said it will be two values. So with bivariate analysis, what we basically be using will be using scatter plots for numerical numerical relationship. And then basically what we need to do will be needing to visualize correlation or pattern between two numerical values. So this scatter graph on the right, it is showing Sterling score with number of hours of sleep. This is just an example. We can see how spelling score is based on the number of sleep. So if we do not want to use this, we can use another type of graph, same graph, but we can use two data types. If it was an employee, let's assume it was an employee data set. We can get let's assume it's experience vs salary. So we can draw a scatter graph showing experience or working experience versus salary. It will show how experience is affecting salary, or it will show how much salary according to the experience. So basically in the bivariate analysis, what we are seeing is we are seeing how two columns, how two features are affecting each other within the same data type, within the same data set. So that's bivariate analysis. Bivariate analysis also can be used to be drawn using correlation matrix and heat map. A table, it display correlation between multiple variables. This, I think, it was not supposed to be here because it's showing a correlation between multiple variables. It's showing iPad and laptop and all that. Was supposed to be showing correlation. If it will be supposed to be in bivariate analysis, it was supposed to be showing only a pair of double of features. To need to show how two columns affect each other. So on the right, we can use a heat map whereby it can show temperature and humidity at the same time. So by bivariate analysis can be both drawn using a scatter graph, can be drawn using correlation matrix, and can be drawn using heat map. The only thing wrong here is the correlation matrix in this, which is shown here. It's showing correlation between multiple variables, but it can be used in bivariate analysis to be able to analyze two columns or two features. Again, bivariate analysis, we can use a box plot for numerical and categorical relationship. The heat map can be used for both, can be used for numerical, because we can have temperature and humidity same in the same heat in the same heat map, but box plot we can combine it for box plot for numerical categorical. Yes, we can use this box plot for showing both numerical and categorical relationship. You can see this box plot on the right side. It's showing both numerical and categorical value. So we can see for Windows, iOS, and Android. And then there's a box plot showing the revenue for Windows, the revenue for iOS, and revenue for Android. This Windows, iOS, and Android, these are categorical value or categorical value. And then the revenue is the numerical. It's showing the relationship between these two. So we are basically showing a relationship between the categorical and numerical relationship. How are they affecting? And we can see these in the front here. We usually call them if there's anything unique that can be happening to the data, we can see them using the same plot, which is box plot. So that is all about bivariates. Any question on that? So we go to the last one, the multivariate, and then we go to conclusion. Starting with the multivariate analysis. Multivariate analysis, as the name suggests, will be having multiple variables that will be analyzing them all in one time. So mostly we will be using pair plots and pair grids. So basically we'll be having we'll be creating a matrix of scatter plots between multiple numerical and variables, numerical variables. So it will be showing a histogram or KDE plots. So when we were learning tools or libraries to draw the charts, or yes, to draw the charts, or yes, to draw the charts in EDA, we learned that we'll be having matplots, and another one was, I think, Seaborn. So I think this one will be using Seaborn. Let me just go on, and then later on we'll be seeing, because we'll be having the actual hands-on demo. So multivariates, here it's this one on the left is using pair plots and pair grids, which will be creating scatter plots between multiple numerical variables. And then we'll be seeing it. It's showing both histogram or KDE plots. It's combining and then it's showing for each column. So if we see on the left, this first column is showing petal width, and the petal width has been drawn using histogram, using KDE, and all these columns. And then the next one is petal length. It's having all these different drawings, tempo width, and then tempo length. So based on how many columns or how many features you need to be able to analyze, you can use these pair plots or pair grids to be able to analyze it by drawing charts, these pair plots and pair grids, and be able to analyze all in one time. In multivariate analysis, we can also use cluster map, which is basically this map. It combines the heat map and hierarchical clustering. You can see in the map, it's showing regions. not only showing regions, it's also showing heat maps at the same time. So it's a little bit difficult to read the legend, but it's basically showing two different, more than several different type of data, which are all presented in the same data. So we can see there's cluster, it's showing clustering, and then it's also showing hierarchical clustering inside the heat map. So there is more than three columns which are presented within the same cluster map. I think that's yeah. So basically, it's showing the heat map of normalized age, adjusted incidence rate of brain and other nervous system cancer from 2000 to 2014 with spatial clustering. So you can see all those features are presented within the same cluster map. So in also multivariate analysis, they'll be using PCA for visualization. But basically, in PCA, that means you will be analyzing all the columns in the data set, and then we'll be trying to check how do they relate to each other. And then we'll need to, okay, in PCA, we will be trying to detect which column are important for basically anything that we want to do or anything that we are supposed to be going on for modeling. So PCA is basically for dimensionality reduction. You having high dimensionality data, and then we will be reducing it to we will be reducing the data so that we will be reducing the data while preserving the variance, how the data vary. So the benefits of using PCA, it's include easier to visually cluster, faster modeling, and remove noise and redundancy. If you'll be doing PCA, I think we'll see it in the hands-on demo. But it's basically if you're having 100 columns, PCA will be reducing the data into a fewer columns that you can use them to do machine learning or to train your model using those fewer columns. So that's basically you'll be analyzing the multiple columns and to see which columns will be fit to be used with your model or to be used with your machine learning model. So that's all about multivariate analysis. Going to drawing meaningful insight from exploratory data insight. When we explored all three types of exploratory data analysis, we check the univariate, the bi, and then the multivariate. What we need to be able to get, we need to be able to draw, or we need to be able to get insight from those data. When you see all the histogram, all the charts that we see, you need to be able to know what type of data or what are you seeing, what does it mean. You need to be able to explain what does the data mean. So exploratory data analysis, it's not only about drawing the plots or being able to draw the plots. That one is important. You need to be able to draw it, but the automation tools are there. But you need to be able to discover what is wrong or what is there in the data that it can help you when you start actual pre-processing the data set and building the model from the data. You need to have it. There is exploratory data analysis. You need to have that insight on how to go on with the data. So how to extract the insights? You need to just ask yourself these questions. What did this chart or statistic mean for the business? You may be having a chart or statistics or histogram which is showing growth in your business. From that, you need to be able to know how is the growth, how was the business was that this chart it showed like the business was growing or it was deteriorating. So all that, for example, for people who are in what is stock marketing, something like that. I don't do it, so I don't understand it well. But there are some charts or statistics that they see that when they evaluate those statistics, they get insight like the market is now falling, the market will now be going up. So same way in EDA, we need to be seeing the insights like if you do statistics on the data set of the hospital of a disease, how much disease, if we're doing a exploratory data analysis on a disease, what's the difference between then and now? If we also assume you're given a corona data set of the entire world today, what do you say? What does the statistics show? Does it show the corona is still it still kills as when it was in 2019 and 2020? So the statistics, you need to be able to see all these insights so that when you apply the data set to your model, you'll be able to see similar trend applied. So it also helps you if you need to extract the insight, you need to also identify the pattern, relationship, or segment of the data which are behaving in a particular manner. For example, when we say relationship, we talked about having experience and salary. If your data in any insight you're getting someone who is less experienced is getting higher salary, you need to ask yourself they could be somewhere wrong with the data. That's why it's not showing the correct relationship. The relationship between data, we usually say it's expected across multiple companies. If you're having different type of data or you have dealt with different type of company, you need to know the relationship between one column and another column. For example, also, if you are having employees data and then you are seeing someone who is 102 as employees of the company, you need to identify, is this the pattern for the entire company? The company is employing people who are all above 100. So you need just to get those insights. Is this real or is data error? So you need to be able to know all that. Another way to get the insight, you need to compare the expected via the actual finding. This exploratory data analysis, you'll be having what is expected. And then later on, after you have the model or you do the research, that's when you'll be having the actual finding. That's when you'll be having a means to be able to compare after actual finding or after actual research, how was the data was. For example, your insight from the data set, it's showing, let's say, corona has now decreased in the world. But when you go create the model, and then you create a model for detecting corona, a machine learning model, and then your model with each row or with each feature that it's given, it's showing everyone has corona, everyone has corona. That's the actual finding from the model after you develop the model. So when you compare it with the expected, with the evaluated data analysis of the data set, you'll need to be able to tell it can be the false positive, the model is behaving incorrectly, or your exploratory data analysis wasn't as expected. So either way, you can get insights from there. How the either influence modeling. I have like 3 minutes, so I'll go a little bit faster here. So since you are already you'll be exploring the data. If you're having linear trend, you'll go with linear regression. If you have non-linear trend, that means you'll be going for tree and all other types of algorithm. For feature analysis, if you have skewed data, you'll have to apply the log transformation. If you have high correlation, you'll have to drop redundancy. If for data pre-processing, you know when you do EDA, you'll be able to detect if they are missing value. So you will see whether to apply imputation strategies or dropping strategies as we learn. If we have categorical variables and we want to use linear regression, that means we will need to go for encoding these categorical variables so they become numerical, so we can be able to deal with them or to handle them easy way. And then we have the matrix selection. If you're having class imbalance within your data set, you will know not to use, you need to be using F1 score instead of accuracy. If you're having class imbalance and you use accuracy, your accuracy will not be correct. For example, if you're having 1,000 instances of rows, this 1,000. And then out of these 1,000, only 300 they are diseased. and then you are applying this data set so that you can train. Meanwhile, the healthy rows are 700, while the diseased one are 300. That will be creating class imbalance. If you're having class imbalance, you'll be advised to use the F1 against using the accuracy of the entire model. Communicating the finding. This at the end, the EDA, the most important part, it will be able to communicate the finding correctly. So you need to use simple and visualize summaries, and you need to focus on the business impact, not just the technical stuff, just the coding. And then you need to tell a clear narrative, like you notice X in the data, you suggest Y, and then you recommend Z. It need to be clear. And then these are just common pitfalls. Yeah, I think we should stop since it's 10:30, and then probably we'll pick up again later on while we're starting showing the demo and hands-on.
Okay, guys, you can like take a short break till 12 p.m. Then we will resume.